Hello everybody. Today I want to present to you one of my projects. First of all, I need to tell that the goal of this video is not to teach you something and is not to share with you with some secret knowledge, because I am not a radio engineer, I am not an engineer at all, more I don't have any technical education. So this video first of all is for my friends. I want to share with them with results of my hobby and my work in this hobby. Unfortunately, I live very far from a lot of my friends, and that's why it's only one way to share with them with this. But if somebody can find something interesting in this video, I will be very glad in this case. And if somebody has any questions, with pleasure I can answer these questions, of course, if I am able to answer. Because I want to repeat again that I am not a radio engineer, but with pleasure I can share with my knowledge I earned while I was doing this project. And additionally, of course, this video is a way to tell thanks to my friends who helped me with different advices. And I want to tell thanks first of all to my friend Sergei Tavkach for general technical support, for Grigory Skalatsky for very good firmware, and for Andrew Garlachev who helped me a lot with woodwork. Thank you, friends. Okay, now let's start. Like a lot of people, I like Neon and I like Nixit lock. I like Nixit lock very much, and a lot of years ago I did some projects with Nixit lock. Predominantly I did it with in 12 and in 14. These are old Soviet indicators, but they were rather usual projects. Some of them I did myself. No, I repeated different projects from internet. I'm not a radio engineer, so that's why I couldn't develop design myself, so that's why I repeated. But all of them, they were rather usual. No, only one project I can tell that it was rather special, because here I used generator, stable generator, thermostat stable generator from old frequency meter, Soviet frequency meter, and with this thermostat stability and was very high, and accuracy of this clock was rather high, only few seconds error during 1 year. One day on Radio Market I found this lamp. It's a ESSH-400, ESSH-400, so it's a lamp for speed photography. It's filled with xenon under high pressure. I didn't find, I found, but information is controversial, from 2 to 10 bars inside pressure. But the main is it looks nice, it looks very nice. So I wasn't going to use it like a flash lamp, but I thought, how can I use it like a souvenir? It's okay, but I wanted to force this lamp to do something. And one day I had an idea to do a clock with this lamp, and I just wanted a small sparkle in this lamp which just imitates seconds.
sound imitates sounds of seconds and just count seconds. So it was my idea, and all time after I tried to realize this idea. Okay, I bought a kit. I asked one of the developer of this kit to modify firmware for me, to have one signal from microcontroller to rule high voltage converter, to open transistor, which has to give this sparkle. So at that time I realized this project rather comparatively fast during my leave. And you can see results. I was very glad. As for me, it was beautiful. It worked like I wanted. But after this, I was disappointed because actually it started to give me problems. Now I need to give you my excuses, because that time, actually it was 10 years ago, and that time I didn't do video. I took pictures only, and video I took only a very small part of this sparkle in lamp. So that's why I am sorry, but now I need to explain what was the problem and show you only photos, pictures. Okay. The first problem I faced with it was reliability of high voltage transistors. I used a few high voltage power supply. This one I made myself based on 555 the 55th timer. Another one I used, I soldered it with help of my friend. But both of them, they store rather high voltage, approximately 500 volts on capacitor, and after this high voltage MOSFET discharged on coil, which I did using a transformer from black and white TV. This solution, it was very powerful. It gave 40, 50 kilovolts, maybe even more. It wasn't any problem to give a sparkle in high pressure xenon. But during first weeks I was using my device, I changed few of these high voltage transistors. Despite I bought brand new transistors which were designed for 6 and 800 volts. In my system it was approximately 500 volts, a bit even less. So despite this, it worked few days only. So that's why I understood that that time high voltage transistors were not very reliable, and I decided to change design. With help of my friend, I designed power supply like this. So as you can see, there are two separated parts, high voltage and data signal part. High voltage part, no, it's not a high voltage part actually, it's a power part, yes. There is a power supply, just usual transformer, then few electrolytic capacitors and another capacitors, so they storage 12 volts, and there is a rather usual MOSFET. This MOSFET, when there is a signal from clock, it opened and discharged all this energy to high voltage coil, ignition coil, actually from car. And output of this high voltage coil goes to lamp. Now here there is my device. So as you can see, it's completely divided by two parts. So it's divided, isolated by optocouple. Here, this is a digital part and entrance of signal. Here there is a power supply part, so it's an entrance of 220 volts. That, let me switch off this layer. Okay, so this is entrance of 220 volts, transformer, then rectifier. After rectifier, there are two capacitors, only these two. After this, there is a stabilizer, 7812, and after this stabilizer, there are four these electrolytic capacitors and other metal and ceramic capacitors. No, and power MOSFET after this. So a digital part, first of all, power supply of digital part, it's separated part. I took it from digital part of clock. Then signal seconds from clock, it comes here. And here there is a first microchip, it's a Schmidt trigger. Schmidt trigger I used because in first realization of my project it was one another problem. Sometimes instead one sparkle a second, so I had a series of impulses, a series of sparkles, 3, 4, 5. I think it's because of interference and because of self-induction. Because of this interference. That's why here I put a Schmidt trigger here to avoid this, to have a one separated strong impulse after this. After this, as I already told, there is optocouple. Here this is a power supply of another chip. Another chip, it's a multivibrator. Multivibrator I put here to form impulse with some particular length. It's easy, of course, to do it in microchip, but as I told you, I bought a kit and I don't have possibility to change firmware. So developer changed once for me, but I wanted to have possibility to do some experiments with different lengths of this impulse. No, it depends how long is this transistor has to be opened, and during how long time this capacitor can discharge their energy to high voltage coil. Okay, so that's why I put this multivibrator here, and actually this is a capacitor which depends on this capacitor's time of opening of this transistor can be changed. This is another optocouple, another optic isolation. And after this there is a driver of this power MOSFET. And actually that's all. Here it's a protective diode. Here it's a LED, green LED, which I used in lamp, and because this LED it's located very close to sparkle, to source of interference, so that's why I decided to take power supply for this LED from this high voltage part. And actually this is out of this 12 volts to high voltage coil. This is my device. The next problem I faced with, it was a corrosion of electrodes. I opened lamp. I drilled a hole. No, actually I did it twice, but why did I do it second time, I will explain later. Actually, this is the main theme of this video. But first time, 10 years ago, I opened this lamp because I was stupid that time. I had never worked with high pressure before, and actually I was afraid that this lamp can blow up. So I saw some video of different lamps, xenon lamps of very high pressure, which can blow. But after I found that it can be, it's applicable only for tube light lamp. After a lot of time they worked, and something like this. For this, it's almost spheric lamp, and after I found that glass here it's rather thick, so that's why it was very stupid. It was very silly to afraid that it can blow up. More if it's a new lamp which didn't work. More when there is a normal temperature, room temperature inside, pressure is comparatively low. Even if it's filled with xenon with 10 bars, so it can increase when it works like a flash light. So in this case, during flash, when temperature is very high, this pressure can be 4-5 times higher, up to 40-50 bars. During some milliseconds maybe. But if I use it just to receive a small sparkle between electrodes, of course it was very silly to afraid of blow. And that time I didn't know this, so I drilled electrode. I opened this lamp, and I did it in basement with rather high humidity. And of course air came together with water inside. Actually, I tested this lamp after these few days, and I thought, holder is the most probable. It was made from stainless steel. Electrode is from tungsten, so that's why there is no any problem with this water inside. So it was difficult to see some small dots of this water, but I wasn't right. After 1-2 weeks of using, I don't know exactly, but I think situation was next. Sparkle, temperature and pressure inside sparkle is high. It leads to producing some quantity of nitrogen, and this nitrogen reacted with this water which came inside lamp, and that's why it produced some nitric acid. And this nitric acid influenced on electrodes and gave a corrosion of this electrode. And lamp became not so beautiful like it was. Moreover, it changed conductivity, I think, in lamp, and it influenced on interference inside. and that's why that project worked a few days, maybe 1 week. After this, it started to give interference. More interference. No, about interference I will explain a bit later. About interference, it worked few days, as I told, but after few days, when lamp started to become a bit brownish inside, it started to give interference. Clock started to reset from time to time, and as longer as shorter this period of time. So that's why I think this dust of some oxide, it changed conductivity inside this lamp, and it started to give more interference. No, this problem with clock itself, it was solved rather easily, because problem it was connected with Mega 8 microcontroller, and developer of this PC board, he didn't think that this clock has to work in some aggressive environment with a lot of interference, and that's why a lot of legs of this microcontroller wasn't connected with ears, so they were just in air, and that's why they worked like antenna. So I modified this motherboard, no, PC board, a bit, and after this problem with influence of interference on clock, it has disappeared. Lamp I changed for another one which I didn't open. So it was a usual lamp which is filled still with xenon under high pressure. It worked very good, but it worked itself. So clock, it worked nice, but it still gave a lot of interference on environment and on equipment which were located near this clock. Even some sensitive devices, for example, my monitor Philips, it reset from time to time, despite it was in another room in distance of 20 meters or something like this. So, but that time, it was 10 years ago, and that time we were forced to leave our city Donetsk because of war, because of Russian terrorists occupied our town, and we went to another country. I took my clock. I thought that when I have time, I will finish this project, and I have been waiting 10 years and didn't have time, and eventually decided, okay, it's time to finish this project. I took it from box, I assembled it, and clock itself, it worked nicely, but again, interference influences and influenced on some devices around, as you can see here. Here you can see what is the behavior of oscilloscope near this my device. Because of interference, you can see spikes So, and this is oscilloscope with battery power supply, so it is not connected at all. There is no any connection to main line or something, so that's why it's not connected with main line. It's radio frequency interference. The same with multimeter. Multimeter was going to switch off, and because of interference, it's switched on again. This oscilloscope, it has a galvanic isolation. But again, because interference on radio frequency, if I work like antenna, if I touch electrode, yes, you can see every second spike, and you can see this interference on the screen of this oscilloscope.
Ну, понятно, что передается, как бы. Причем, помнишь же, осциллограф у меня с гальванической развязкой. Ну, ладно, Райгал с гальванической, а этот от батарей. И вон сейчас вообще линия вниз ушла.
This video I took to show how does it influence this interference on monitor. Actually, in Donetsk it was the same with Philips monitor. And here the problem is with Philips monitor, so it is not protected from interference. Now I have switched on my device. Now look at monitor, and sometimes few minutes, sometimes few seconds. It's reset. HP continue to work. But sparkle in xenon under high pressure is so white, fat, beautiful. So that's why before drill lamp and open it, I tried to solve the problem with another way. First of all, I tried to use different small coils from TV, from motorbike, Engvision coil, from defibrillator even. But energy of sparkle during using this coil, it wasn't enough to break down xenon under high pressure. The next moment it's a quality factor. No, actually this is a transmitter, radio frequency transmitter, sparkle type, and this is a oscillation circuit with unlimited quality factor. So that's why first of all I tried to use instead usual wire, I used wire with distributed resistance, 15 kiloohm per meter, and additionally after I added a resistor 100 kiloohm, but it didn't influence on situation. The next thing I tried, it's a capacitor. It's a capacitor between primary coil of high voltage transformer and ground. It's a standard common way to decrease interference from Engvision system. Actually this capacitor, it's a bypass for high frequency current and respectively high frequency interference, and it's now this capacitor is installed in all modern Engvision systems, but I have tried different capacitors, but I didn't see any significant changes. There is some improvement, but it didn't influence on situation dramatically. I even tried to use high voltage capacitors. No, maximum I have for 5 TV. I put it in series connection to have 20 TV at least. And I wanted to decrease this high frequency interference from high voltage side. No, it was a silly idea, and of course it didn't work. Unfortunately, I have used all solutions I knew to decrease interference. At least electrical solutions. So at the same time, as you can see, here there is a broken lamp. I broke it during next experiments. Epoxy resin came inside lamp. Okay. Actually, as you can see, it's broken. Respectively, the pressure is just usual atmospheric inside. And when there is a sparkle under usual pressure, under atmospheric pressure, the system doesn't give interference at all. No, it gives, of course, but this interference is not significant enough to influence on work of my devices. The most sensitive to interference is microscope, which is nearby. So that's why, as you can see, it works normally, in contrast to sparkle under pressure. So that's why it's connected, this interference. It's connected with some resonance, which happens under some particular pressure. I tried to use different distance and to check breakdown just in air, even without lamp. And as you can see, I tried to extend this sparkle distance up to 2, 3, sometimes up to 4 centimeters even. And despite bigger, longer distance, respectively much more visible and significant sparkle, it doesn't give interference enough to influence on my devices. So it works normally. Here I tried even to increase up to 30-40 millimeters distance for sparkle. If it's higher, so it happens even breakdown from this high voltage wire to coil, to string shield of this coil. But if it's within 30, 40, maybe even 50 centimeters, so it gives this sparkle. And this sparkle, it's 5 centimeters, so it's approximately 50 kilovolts, and energy is high, but it doesn't influence on this microscope and monitor, any device at all. So if there is interference, it's not significant enough to give problem. To check my theory about resonance and about some particular resonance under some particular pressure. So I took another lamp, another xenon lamp from some stroboscope. I didn't find data about pressure inside, how high is it. But it's definitely different. It's another, it's another pressure. I tried to use it. And it's much better. There is some interference, but microscope, for example, it can work a few minutes sometimes, in contrast to that my ESSHA 400, which forced to reset this microscope from first ray, from second breakdown. That's why it's really connected with pressure inside lamp. Maybe form of electrodes and some maybe other factors influences, but first of all, I think it's a pressure. By the way, good and nice lamp, and I want to do another project with this lamp as well. Okay, here I have clearly realized that there is no other way unless to open this lamp and decrease pressure up to atmospheric pressure. Atmospheric pressure of air, by the way. No, actually no. Xenon is more heavy comparatively to air, so that's why if I don't blow up especially this lamp, so the most probable it will be some significant percentages of xenon there. So, but I decided that better is to decrease pressure even less than atmospheric pressure. No, first of all, I needed to dry this lamp. Second one, no, I thought that if I decrease pressure, so I need less voltage to break down this distance between electrodes. And to confirm this, no, I knew approximately, yes, but to confirm this, I started to search information, and I found experimental so-called curves of Paschen for different gases. And here you can see this curve for air. So, and yes, there is a confirmation that as lower pressure, as less voltage I need to break down this distance, but up to some particular pressure. So after this, if we go lower, no, I think because it's lack of electron after this border, and in this case I again need higher pressure. So that's why I have realized that I don't need any deep vacuum, so I need to decrease pressure up to 0.1 millimeter of mercury, what is approximately 100 and a bit more pascals. So, and moreover, I was sure that I don't have a pump which can go deeper. So no, I think ideally it's to reach this 200 pascals. It will be enough to decrease voltage and respectively to decrease energy and respectively to decrease interference. Okay, my idea, it was connected with air conditioners. No, during installation, usually technician, they attach vacuum pump to air conditioner, and during few 10 minutes or few hours, they force low pressure in system to dry the pipes, to dry everything inside the air conditioner, to remove humidity, to avoid blockage of capillary of air conditioner. So my idea, it was the same. I wanted to attach vacuum pump to this hole. Actually, this electrode, it's 8 millimeters, and it fits to vacuum pipes I have. So this vacuum pipe just very good fit to this electrode. But before, I wanted to put here epoxy resin. It was difficult to find epoxy resin here. We have here only epoxy resin like a glue with hardening time 2-5 minutes, but it's difficult to find a small portion of epoxy resin with hardening time few hours, but I found a bit. So, and I wanted to put this resin. I wanted to put this vacuum pump, start this vacuum pump, and during few hours just dry this lamp. But despite hardening time few hours, I found that in few minutes viscosity of this epoxy resin become higher. So that's why pressure, difference of pressure, here it's lower, here it's higher. So I wanted this epoxy resin to boil. Water comes, no humidity, air with humidity goes from here and goes to pump. But because high viscosity in few minutes, so this difference of pressure here and here, I think it is not enough this air to go this way. So that's why it's not a good idea, I decided. Because this pump will work really only few minutes. After this viscosity become so high that this air can't go through this viscose resin. So that's why I changed my plan. I decided to connect this electrode without epoxy resin, start pump, keep low pressure during few hours. After this, add epoxy resin with help of syringe. Just inject epoxy resin here. After removing of this epoxy resin with syringe with epoxy resin, just close this hole from needle of syringe with help of duct tape. Pressure goes not from here. Pressure will try to close this hole by pressing of this duct tape. Okay, but additionally, I decided that it's a good idea if I can reach some differences in temperature. For example, if this lamp can be hot, so in this case more air with humidity comes out from this lamp. So that's why I decided to add some hot air here. But after I decided, okay, but it's good here to reach some low temperature, not just because of difference hot and cold air. Yes, it will help a bit to move air from here to here, but additionally I wanted air to condensate here. So if I can reach some low temperature here, so this humidity from air will go to wall. And I started to think about something like a fridge. So I have some Peltier thermal elements. I usually keep it like a spare for my water cooling system. So I wanted to add a cylinder here. So some cylinder, on this cylinder Peltier thermal element, it will help to reach some at least cold surface, at least some part of this cylinder, not all cylinder, but if some surface could be cold, and if we keep this system working during few hours at least, I hope that almost all humidity, almost all water will condensate on this wall, which is close to Peltier element. So what do we have eventually? no, like idea at least. So this is hot air. Hot air blow hot. This fan blow hot air to this lamp. So this hot air goes to this cylinder. This cylinder has a cold wall because of Peltier element, and humidity will condensate here. No, and comparatively dry air will go to pump. No, it was good, of course, to reach so-called triple point of water and go a bit down to receive so-called lyophilization, when water directly will convert to ice crystals. But in this case, first of all, I have an experience with element Peltier, and I understand that I can't reach so cold temperature. And here there is no very big sense, just usual condensation, it will be enough. Okay, we'll try to realize all this. For fridge, excitator and vacuum receiver together, I decided to use a cylinder from oxygen concentrator. It fits very nice for this role, but only one problem, it's a shape. There is no flat surface to put thermal element Peltier, so that's why I need to do something like a converter. Так, I glue a sandpaper directly on cylinder to have possibility to make it the same shape to increase surface of contact, thermoelectrical contact. It took few hours, but now I have approximately the same shape like on this cylinder. Thermopaste, and it will be okay and good thermal connection with comparatively low thermal resistance. Unfortunately, this is the thickest piece of aluminium I have. That's why if I do the same shape completely, so in this case it will be very, very thin in the center, this piece of aluminium, and it could be easily broken. So that's why I didn't finish completely. But approximately 30–40% of the surface will be very good connection to this cylinder. These sides I will put thermal. Here I will put a thermal paste. Here something like a thermal gasket. And totally it has to be rather good thermal resistance, comparatively low. I realized lamp this way. There are springs, it's approximately 15–20 kg. I am afraid to give more because I am afraid track of a Peltier element. Okay. It's a first test of my device. I want to find out what temperature can I reach with help of one Peltier module for 50 watts. Okay, let's switch it temporarily over. And let's check temperature inside. Temperature is around 15 degrees of Celsius. If we surface is around 16, I tried to put a correct coefficient for aluminium, but it shows minus 20 degree, which doesn't look true. In this case, it's the same data like on that thermometer. Additionally, there is a condensate. Don't know, connect this in. There is a condensate directly opposite Peltier module. And I did a mistake. I put this insulation after I mount everything, so that's why this aluminium, like, it has a direct contact. Surface is not very big, but it's enough. I can see that thermal resistance is bad. No, it's good actually, but cold goes out. So from inside on this leg, and it's completely wet, it's completely covered with condensate. Okay, I have changed and improved insulation, so removed that direct contact between aluminium of cylinder and aluminium of legs. Then I added one another Peltier element. I added thermometer, more convenient, and now I can reach approximately 7-8 degree of Celsius. No, during room temperature, approximately 28 degree of Celsius. So I used valves from autoclave. But there is a problem. There is a leakage somewhere, so it doesn't keep pressure long period of time. Because I dismounted them from autoclave, I suggested that it's because of scale inside, because sometimes maybe somebody add not distillated water there. And I was right, I disassembled, I found a lot of scale, I used special chemicals, so removed it, and it became much better, but still there is some leakage. And this time I started to think that maybe a high pressure pump is not applicable for vacuum at all. I didn't know that it's like this. I didn't I haven't worked with them before. So, and I was right, as I found in future. I have cleaned valves. It became better, but still it loses pressures. Not a lot, but loses. So I decided to put two valves in serious connection. Initially I tried to put it with different direction. Maybe each of them it can look like a non-return valve. But it doesn't. It's not bad, but it's still losing pressure. So that's why I think that these valves, they are not designed to work with vacuum. Actually, it's written here that they have to work only with positive pressure from 1 to 0.3 megapascals. So that's why I think it's a problem. And actually, material of valve, it looks like it's it's not a soft
rubber, so it's something like plastic. So for higher pressure, more reliable, but it doesn't want to work with vacuum. So that's why I tried this type of valve I have. It was installed on vacuum device, so it's at least designed to work with vacuum. Valve itself, it has rubber surface. Unfortunately, I don't have this type of coil for 220 volts, so I improvised a bit and put transformer to 110 volts. So no, this it works much better. Так, now I want to exclude leakage somewhere here. So that's why I disconnected cylinder at all, and directly entrance pump I connected through these valves directly to vacuum relay. Here it's opened, I will close it. So let's try. It means that leakage is possible only here. So the most probable these are valves. They are not designed to work with vacuum. So 100% it is. Okay. Let's try now this which was designed for vacuum. Так, okay. The same. Now it's directly through valve. It's connected to vacuum relay. So without cylinder is excluded from system now. So no, if it's cylinder, it gives some inertia, and that's why it's better. But if it's connected directly here, so we have volume only inside these hose pipes. So if it's a problem, it will switch on, switch off constantly. If there is no problem, it will be comparatively stable. Okay, let's try. Okay, it loses a bit, and it's without cylinder, so with cylinder, like a vacuum receiver, it will be, I think, much more better. I think this difference in 1 Pascal to lose from this cylinder, it will be at least few minutes or maybe few 10 minutes. So we'll try now.
No, and this is eventual view of my device for vacuum and drying of my lamp. Так, now the question is a pump. I have few pumps, vacuum pumps. All of them I bought it from scrapyard. Even this pump. So it's I found it on scrapyard, very dirty with excrements of mice. But after I cleaned it, I found that condition is very good. It looks like it didn't work a lot. I think jars were broken and they put it in basement and it spent there long period of time. Despite it no average Chinese quality, I can tell. So, but it works nice. So when I disassembled it, it looks. No, I have an impression that it didn't work at all. So like new inside. So that's why it's a confirmation that they or lost or broken these jars, and after this throughout it. So it works rather quiet. It gives approximately minus 87 kilopascals. So no, and I think it's very good for this my experiment. But additionally, I have some another pumps in different conditions. Some of them don't work, some of them works, but I even didn't test what is real pressure they can reach because I bought digital vacuum meter recently, no vacuum relay actually. So that's why I am going to test them and to service some of them. After this, I want to compare and to take the best and use it in this my experiment. Third, this one I have, it's from some typographic machine. So, okay, let's check. I checked it only with analog this one I vacuum meter. Так, let's try. Okay, it gives maximum minus 60 kilopascal. It can be used, but I have better variants. So that's why this one I'm not going to use kilopascal, at least now. It can be used, but that my next device with vacuum pump, it's a vacuum dental mixer. So I removed vacuum pump from here. It looks very good actually, but it doesn't reach pressure which it has to reach. So that's why I think it was throughout. But I checked, membrane is okay, everything is okay, there is no any leakage. If honestly here I didn't understand what can be the problem, because separately everything works very good ideally, but it doesn't reach normal pressure. Additionally, this pump, it has some mystery. So I couldn't understand for what is one valve here. So no, everything other is clear, yes. So it's pump itself, membranes, but this valve, it's a mystery for me. So no, as you can see, all pipes, manometer, vacuum meter. So this is entrance for air, filter, then this double membrane. But this pump, this valve, it's a mystery. First of all, it's closed. From other side, it just closed. And as you can see, this is American 110 volts valve. The same time, motor it's at 220 volts. And on PC board, no, there is a usual power supply for microcontroller, so it's a 9 volts. There is no anything which can be inverter from 220 to 110, or just on the contrary. So there is a mystery valve. First of all, it's another voltage. A second one, it's a closed valve, but it's connected. It's connected with pipes. It was connected with wires, but I can't understand what can it do here. The next pump I have, it's very interesting for me because it's very old, almost antique. So it's General Electric 1953. So it was made 1953. So it means that it's 71 years old. Despite this and despite appearance is very bad, but inside condition is like new. But it didn't work. It didn't work, and when I disassembled, I found that problem is with this internal switch. I didn't understand for what. One my friend explained me then in USA that time it was they were electrical rules, and due to these rules any device had to have some internal switch. So you can't use it only with external switch. You couldn't. And this device is very serious. It's very heavy, 25 kg. You can see it's even entrance. It's made like IP68. For what I didn't understand, but it looks like earlier people did things really very. It looks very strong. It looks like it was designed to work 1,000 years. So I decided to disassemble it completely to service, and it was very interesting for me because before I have never worked with this type of electrical motors. So I worked only with Tesla modern type with capacitor. I didn't have a deal with motor with bifilar start coil and with centrifuge switch. So that's why for me it was very, very good experience. So I restore it. It looks very, very, very nice. So I like how does it look. It's just its place on shelf on museum.
Так, okay. I have assembled motor. I hope that problem has been solved. Resistance is okay. It's approximately 9 ohms. Let's try. Oh, nice. So problem it was with this switch. Just mechanical damaged. No, and maybe vacuum was not so good because very old oil. No, additionally, I cleaned a bit centrifuge switch. It could stuck because of some corrosion on it. No, I hope now it will work normally. No, at least motor works perfect. Now it's turned to assemble pump. Hop. Now it could be here. Work of centrifuge switch. It switched on start coil, and it was a sound of brake. Okay.
I have assembled everything, so it has been working already approximately half hour. It works very quiet despite now it's without vibroisolation, and despite half hour it's still very cold. But pressure is not very no, deep vacuum, yes. So it gives approximately minus 60 kilopascals, so it means approximately 40 kilopascals of remaining pressure. I think it was designed to work very long time and to be very quiet, but it doesn't need to give some very deep vacuum because it's just a suction unit. No, eventually it's clear that for my experiments this modern Chinese pump is the most suitable from all pumps I have. Additionally, I decided to check serious connections of pumps. So I saw and I was sure that it can give lower pressure if you put pumps in serious connection. And I was surprised. No, this pump it gives minus 80. This pump it gives minus 87. Together in serious connection it gives minus 88. So difference is only 1 kilopascal. What is the most probable? Just error. So it means that there is no any advantage in serious connection, at least these pumps. I am very surprised, but no, okay, we'll work with one pump. Okay, eventually it's time to start a real experiment. So I need to drill to open the lamp, and I need to be very careful. So I mustn't force drill bit to go deeper because holder I need to drill. It's from stainless steel and rather soft. This electrode is from tungsten, so that's why I can't drill tungsten with usual drill bit. As you can see, very important moment because of high positive pressure inside. This metal dust after lamp is opened, it's blow out. It was blow out, and it's very convenient. I didn't think about that moment. It's very important moment, and we'll come back to this moment in future. Now let's start the main part of my experiment. This my device is working. It has been working already approximately 4 or 5 hours. Temperature is around 8 degrees of Celsius. Fan I used initially 100 degrees of Celsius. Pressure is minus 84. My house is located rather high, approximately 1.2 kilometers, respectively. Atmospheric pressure is 90-91 kilopascal, respectively. Remaining pressure in lamp it has to be approximately 6 kilopascals. No, and now after 4-5 hours of vacuum, I am trying to inject epoxy resin inside. No, first time I wasn't sure, so vacuum pump was switched on immediately because pressure went up immediately when I pricked this vacuum hose pipe. Now I am using the same hole. I injected more epoxy resin. Sorry, this moment I forgot about camera at all. No, and now you can see this epoxy resin is boiling. I have closed this hole, and I did one main mistake here. I didn't think that this epoxy resin is so liquid. So I didn't expect that it went inside lamp. I thought that it stops in vertical part of this hole of electrode. I didn't expect that it will go to side holes and will go to electrode. No, this way unfortunately I spoiled one my lamp. This problem, after I solved it, of course, very easily. So just small cotton wool. Before epoxy glue, I pushed it with help of some wooden stick, and it prevents epoxy resin to go further. It works something like a filter, so it allows air to go out, but it doesn't allow epoxy glue to penetrate this barrier. And now you can see like air is coming out from lamp. Epoxy resin is boiling, so as I suggested, and now almost everything is due to plan except first lamp is spoiled because of epoxy glue is inside. After a few hours I removed hose pipe and I found hot epoxy glue here, so I drilled a few millimeters after this to release thread to not to attach wires. Now here this is a spoiled lamp with a spoiled electrode with epoxy resin. Now here I'm just checking that pressure is really low inside lamp. I can remember how behavior with this generator with normal pressure and high pressure. And with low pressure, yes, this form of breakdown is completely different. So that's why it's something like a visual checking. While I was playing like a kid with my new low pressure lamp, low pressure toy, so very big surprise was waiting for me. Actually, I concluded wrong that as lower pressure, up to 1 millimeter of mercury or 100 Pascal, as lower pressure, as low voltage which I need to break down distance between electrodes, as lower interference. I wasn't right. So when I connected this lamp to my clock, and I started it, so it started to give even much more interference comparatively to xenon under high pressure. So it gave interference and forced to reset some devices not only around my working place. It gave interferences to some devices in neighbor rooms. So it looks like I have made a system of electronic warfare. By the way, first systems of electronic warfare, they used a sparkle, powerful sparkle, to give interference and influence on enemies' radars and radio stations. Now here you can see that the first sparkle influences on monitor of microscope. From second, third sparkle it goes to reset and switch off completely. Now I have a theory. As you can see here, now instead just break down between electrodes, between two diodes, sparkle between two diodes. Here I have something like a coron discharge. I'm not sure, or maybe it's a like a sparkle around this corn, but I think it's connected with surface. Surface of this corn is higher, it works like antenna, and it increases powerful of this interference, and maybe it gives more wide broadband interference. No, initially I thought, no, okay, it's not a very big problem. I just need now to, no, I was sure that, no, because during atmospheric pressure everything is okay. So now problem is connected with some resonance. So, and changing pressure a bit lower, a bit higher, so I can reach situation when there is no any problem. No any interference, but there is one big problem I didn't think about, and problem now it's changed pressure. Initially it was positive pressure, and as you could see, when I drilled lamp, when I opened it, it blow out this positive pressure, blow out all dust from drilling. Now just on the contrary, when I started to drill, when I drilled it, this epoxic resin, this dust, epoxic dust, it was sucked inside. So, and after this I tried to wash it with different solvents, with different spirits. I tried methylic spirit, ethylic spirit, I tried isopropylic spirit, but nothing couldn't give me enough result. To try something more aggressive, I was afraid, because no, it's definitely some aggressive substances could damage electrodes. So that's why it was a problem, and here on video you can see my attempts to clean it, and despite cleaning, no, despite washing, as you can see, no, now this lamp is drying, but there are a lot of particles of dust remaining on glass, so which is not beautiful, so no, which looks ugly. So no, really it's a problem. I found only one solution of this problem. I decided to drill and open the second electrode from another side to have possibility to wash it under pressure. So I injected some soap inside, and after this, now with help of my son, I am trying to wash it. So fortunately I have rather high pressure in my water system, about 5 bars. So, and despite these small holes, the stream is comparatively okay, and it washes out all these particles of dust. Very unusual, of course, I understand it's very unusual using of lamp like this, but unfortunately I didn't find any other solution. Maybe if somebody can give me some hint, I will be very glad. No, and it's surprise, but it's comparatively worked normally, so it cleaned this lamp. So the problem now is water inside. No, of course, actually I built this exsicator, vacuum exsicator, for these purposes, to clean this water, to dry this water, sorry. So, and now I am drying this lamp. So no, so it takes some time, of course. But after this water, because it's usual water from water supply system, after drying, I found that glass is covered with salts of this water. So, and again I tried to use spirits, but it didn't give good result. Actually, comparatively good result, acceptable result. I could reach only using for cleaning after usual water, just distillated water. Few times I used it, and after this, result is comparatively acceptable. There are some stains of salt still on glass, but you can see it only if you gaze at this glass with good light and from short distance. Okay, I assembled my vacuum device again, but this time lamp is opened. So I need to find optimal pressure for my purposes. So now I started from the maximum negative pressure I can reach, it's minus 86 kilopascals. No, and as you can see, there is a breakdown or sparkle around whole cone of upper electrode. Without light it can be seen very good. No, and the most probable this is a source of interference. Okay, no, and now I started to decrease pressure step by step. So I started from minus 20 kilopascals, and as you can see there is a breakdown, this sparkle between dots only. And after I will check, of course, for interference, and no, at least in this part my theory is correct. So when this sparkle starts to fill this corn, in this case interference became much more severe. Okay, now I am trying minus 30 kilopascals. And this way I am trying to find a border where this sparkle will go from this distance between dots to cone. Now minus 30 is still okay. Let's try minus 40 now. Minus 40 is okay. Maybe a bit this sparkle has started to fill corn, but very not significant surface. Minus 50. It's almost the same, but surface is bigger, but it's still not very significant part of cone. Minus 60. No, and here it can be clearly seen that this sparkle starts to fill more significant part of corn. I think this is a borderline approximately 50-60, minus 50-60 kilopascals. I decreased step for 5 kilopascals, and even this 5, it can be seen that it now each kilopascal it gives more surface which is covered by this breakdown. And respectively surface which transmits some interference is becoming wider and wider. Minus 76. Respectively 15 kilopascals of remaining pressure, and now you can see that from time to time whole corn is covered by this sparkle. Okay, I decided to leave pressure minus 25, respectively approximately 65 kilopascals of remaining pressure. No, I could leave minus 50, but decided just to have some spare. So I took middle of this range, where interference is still not severe. Okay. Now electrodes, because epoxy resin in some time can become transparent to air. So because of some small cracks, so that's why I decided to do this way. To decrease surface of and volume of epoxy resin. So I used bolts, and actually I used two types of epoxy resin. Initially liquid epoxy resin, which I injected during low pressure. So, and after this I cleaned a bit this threading. And used another type of epoxy resin, which is like a glue, and use it just to make more, like to hermetize this threading and space between bolt and this electrode. So both electrodes I did this way. I hope that this will keep negative pressure a long period of time. Now here after experiments you can see this cylinder from inside. There is a lot of condensated water and different liquids. So that's why it worked. Okay, now it's time to work with case. 2 years ago, with my friend Andrei, he is here on video working with wood. Actually, with him we bought some mukva, But we bought just wet, very raw wood. So he dried it, and we went to workshop of another our friend just to initial to plane this wood, to do it straight. After this, to work with our projects in our home workshops. No, and here I am preparing this wood to work. No, it's not only for clock, it's some for clock, for some shelves, for table. So I like very much this mukva. I like to work with it. It's rather hard wood, it's rather stable wood, and I like texture of this wood. No, here there is my son. He is helping me in this process.
Ну, ты возле барабана хорошо там? А, ты уже здесь хорошо все почистил, да? Ну и верхний столик нам еще продуй.
Now I'm working with this wood with just manual router, which I have. I have a small workshop at home, but it's very convenient to work because there is a lot of dust, and even small workshop is better comparatively to work inside house. Unfortunately, I made a mistake. I had initially to use router to dip, and after this I had to drill these holes. Instead this, I initially drilled holes, and after this, when I used router, of course, no, actually before use router, but unfortunately after I have drilled these holes, I understood problem. I hoped that maybe it can be normal, but unfortunately these two pairs of holes, it was okay. Root between these holes, I wanted holes directly, each separated holes for each lamp. So one, it has come out this wood. So that's why I tried to fix the situation. I did like this, but I don't like this. I don't like, I still want separated hole for each lamp. So that's why I want to use plan B. Plan B, I will put material, I will remove all this wood and I will put material that side. So I'd like to use copper, but here I failed to find a copper proper size, copper sheet. So Aluminium doesn't look nice. Stainless steel, no, it's possible, but no, actually I have a few. Так, but I have some damaged motherboards. I bought it from scrapyard in this condition, already broken, but I bought it to dismount some elements. There are very good coils and transistors, high frequency are here, capacitors. Yes, but actually this motherboard is covered with gold, and this part is a solid without any holes. So I will unmount all this, and this I will use like a cover. Polish this gold. I think it has to be nice. I don't have board thick enough, so that's why I am doing this case from two boards. And actually even in one place where is a high voltage transformer, it is not enough even thickness of these two boards. But I don't want to use three boards because it will be ugly completely. So thick case, so that's why I will do it another way. A bit later I will show. No, okay, now wooden part of case is ready. So I like it very much. If honestly, no, not because it's a very good job, because I'm experienced carpenter, not because of wood. I like this wood very much. I like the texture of this wood. I like to touch this wood. It's very, very nice. No, here you can see something like a cup. This cup, I decided to do it like a bathtub for some decoration. I told you that it is not enough space for upper part of transformer, but it's not enough, only 1.5 centimeters. So instead, the third board, I decided to do it like this. No, and this I disassembled old clock. No, and it's like this now. No, like a base for my clock, I used just aluminium from oven. No, it was a pan of oven. So no, it's rather good. I cut, drilled. So no, and you see the result. It's here. I didn't use varnish for wooden part. I used just a wood protector to save texture of wood. This problem started approximately after 2 days after clock has been working. And it's connected the most probable with Chinese thermal glue. I know that there is a polarization of this glue under high voltage, so I was forced to change it for epoxy resin, and after this it became normal. Okay, the clock is ready, but to finalize this project I wanted to update my self-made table. I made a table few years ago, maybe, no, almost 10 years ago. I welded frame. But I used for table itself, I used just cheap board. Now I wanted to update it for wood and for the same Mukva. So I bought it enough, and decided, actually didn't want to install install that lock on that chipboard, which is damaged during all these years. So that's why I decided to renew and upgrade my table. No, actually this work is rather simple comparatively to case of clock. And you can see results. And here you can see everything together. Actually, can you remember I told that eventually I have two lamps. One lamp I opened, I washed it, and there are some stains of salt. Another lamp I couldn't open, but there predominantly there is a dust of metal, not epoxic resin. And initially I decided to install this lamp. So because this dust, metal dust, it was located down, and I think okay, down it can't be seen, it is not a problem. But in couple days, I think electrostatic power just started to move these particles of metal up. So, and you can see, really, of course, you can see it only if you need, if you gaze at it under some, under good light, and on photo it could be seen only when shutter open for few seconds with high diaphragm. With eye it's almost can't be seen, but I changed it for second lamp, which I was able to wash because I was able to drill and opened electrodes from both sides. There are some stains, as I told, of salt, but it's very, very, very. As again, you need to know. You need to know where do you need to see. You need to have some light. And actually, it's almost impossible to see. But in few days, this holder of electrode became a bit brown. I was very terrified. I thought that it will be the same situation like 10 years ago. So I thought, and I think that it's connected with nitric acid. Some remains of water was still in lamp, I think. First of all, I didn't reach the maximum negative pressure, and and I think under this sparkle, nitric acid was produced and influenced on this electrode. But this time it was very small quantity of this nitric acid, and that's why, in contrast to that time when those electrodes became like completely like covered with corrosion, which looks like usual rusty. But here it's a bit. I even can't make a nice picture to show how it is. So it can be seen, but again, if you want to see it. And in few days, this process just stopped. And now, actually, the moment I am finalizing this video, this clock, it has been working approximately 2 months. and that time it has stopped, and there is no any problem at all after this. So it worked stable. There is no any breakdown in some another places, only between electrodes. It doesn't give interference. No, just holders of electrodes became a bit brownish, but it's not very significant. I can't even make a quality picture to show how is it. No, okay, actually this project is finished. Need to think about another project. Thank you very much for watching video. Good luck. Again, if any questions and if I am able to help with these questions, I will answer, of course. Thank you. Bye.